So one of the things that's important with circuits is to know if something is parallel or in series. So if you consider a circuit like this, where we're not going to quite get to complex circuits here in our study, but we can at least look at, what's going to happen here. So if we have the current that's going from the positive side coming around through our resistor, these are in series with each other, right? But something happens here. The current's going to split. Now the current splits because there's a split in the wire, and that's how you know if something's in parallel, is if the current's going to be going in different directions. And so that's important there. All right, so what I want you to do is go ahead and predict on each of these the path of the current. So the current's going to start from the positive sides here, positive side here, positive side here, and I want you to predict what the direction of it. I had them discuss this in class. And so, yeah, go ahead and pause the clip and think through how the current is going to go through, and then you can check here in a second. Okay, so the current's coming through, coming through, coming through. Now, it's not going to go down this way. The reason it's not going to go down this way because there's no negative over here. There's no negative side. There's no potential, so it's not going to want to go down this way. It's going to keep going straight. And then it's also not going to go down this way because there's no negative side over here to pull it down. So it's just going to go all the way around. It's going to completely skip these, not even go through. Like on this one here, it's going to go through. Now this one, it's going to split because it's going to come back together here. But then on this one, it's going to go around, and it's not going to go up. It's just going to continue to go around. It's not going to want to go in here. Then on the last one, it'll go through the light bulb, it'll go through this light bulb. Now, it's not going to go out here to the right because there's no negative side over there. It's just going to continue that constant path all the way around. All right, so today we had some good practice with these circuits, and I'm going to have you practice these. And so go ahead and figure out the overall current, which is going to be what's in this ammeter, and then find the voltage in each. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. Okay, so we bring them all together, 29 ohms. We can get the current, which is 0.414 amps. And when we break it apart here, 3.72 volts, 4.55 volts, 1.24 volts, and 2.48 volts. Because remember, in series, the current stays the same. And so we can figure out how much voltage is used. All right, so let's go ahead and practice this one now. We have a parallel, and we want to find out what is this ammeter going to read, what is this ammeter going to read, and what is this voltmeter going to read. So go ahead and pause the clip and give this one a try. And when you're ready to check, you can hit play to continue. Okay, so we bring them all together. 1 over Req equals 1 over R1 plus 1 over R2 and so on. In this case, we only have 2. So 0.5833 equals 1 over Req. We cross multiply, then divide both sides by 0.5833, and we get 1.7143. Now what's crazy is this amount here is less than even this one or this one, right? So if you add up resistors in parallel, they come out to be even less than those. And so, yeah, we've got that. We can apply Ohm's law, 8.75 amps. And then when we look at this, right, this gets full voltage, this gets full voltage. Remember, in parallel, they get full voltage. And so when we do that, we get 15 volts, and the resistance is 4 ohms. And so therefore, this comes out to be 3.75 amps. Okay? And now you didn't have to solve the bottom one, but that also gets full 15 volts, and the bottom one would get 5 amps through that. All right, so let's practice this one now. How much amperage are we going to read in this ammeter here? And what's the voltage going to be in here? That's all we care about on this one. So go ahead and pause the clip and give this one a try, and when you're ready to check, you can hit play to continue. Okay, so we can bring them all together, and we've got our resistances there, all added up to 14. Set up Ohm's law, 2.5 amps. And then therefore we know that each of these has the same current because the current's the same in series. And that one will have 15 volts. All right, for the last one, we have a 24 volt cell, 5, 6, and 9 ohm. And then we talked about today, this is a different kind of a structure, right? So if this is the positive terminal, this is the negative terminal, you've got the current coming here, and you see how it splits, right? So we know these are in parallel, and then it splits again. These are in parallel. So these three are in parallel. So go ahead and find the overall current, and then the current in each resistor. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. All right, so we should get an equivalent resistance of 2.09. The overall current is 11.5 amps. And then each of them get a full 24 volts. So the top one's 2.67 amps, the middle one is 4 amps, and the bottom one is 4.8 amps. Now, something else that we did in class that I would encourage you to do is to make your own circuit, solve it. You know, it could be series or parallel. And then go to Google search and you can search for the simulator and then test your circuit, see if you got it.